Okay guys, here we're going to be introduced to a new way to think of how to divide up a circle. Alright, so a long time ago in ancient Greece, some very smart people, much smarter than me, decided a circle should be divided up into 360 equal slices. Okay? They decided to call each slice of the circle a. What do you think that is? Well, if you don't know, you should know. They decided to call it a degree. And all they did was said, all right, I'm going to take this circle. Here's the center of the circle, and I'm going to divide it up into 360 slices. Okay, and each one of those slices I'm going to call a degree. Okay, and we're going to say that each degree will represent 1/360th of a circle, which means, right, that there are 360 degrees in a circle. Okay, that's something you're probably comfortable with, right? We have these little bit of tiny slices, okay? And if you were to put all those slices around the circle, there'd be 360 of them, all right? And it's something you're probably really comfortable with, right? You're probably really comfortable with circles, okay? So much so that you can probably tell me how many degrees are in certain portions of a circle. So in half a circle, right? How many degrees are in a half a circle? Well, you probably just know that's 180 degrees. What about a quarter of the circle? Well, a quarter of a circle is 90 degrees. 3/4 of a circle, that might be a little bit harder, but I have confidence you'd be able to figure out it's 270 degrees if you weren't sure about that to begin with. Okay, so we're really comfortable with circles here. I almost think of it in terms of a language, and I think about you're really comfortable speaking in degrees, right? If I say 180 degrees, you just kind of know that's half a circle. If I say 360 degrees, well, you kind of know that's a full circle, okay? And you're really comfortable with it because that's the only way you've been taught so far, and that's totally understandable. But that is about to change, okay? So let's go to the next page here, okay? Let's think about this a little bit more deeply, okay? A circle doesn't necessarily need to be divided up into 360 pieces. Why does it need to be divided up into 360 pieces? Maybe I could divide it up into 2 pieces, okay? In reality, it could be divided up into fewer pieces, right? So in the 1700s, some mathematicians, and there's some debate as to who in fact actually invented this method. But in the 1700s, some mathematicians got together and decided to divide up in a circle in a more logical, okay, when I say logical, at least a mathematically more logical way. Because when you think about it, why is a circle divided up into 360 pieces? It's really kind of arbitrary. Okay, they had some reasons for doing it, more had to do with how they actually count up numbers. We use a base 10 system. But there's really no mathematical reason to divide a circle up into 360 small slices, okay? So what they decided is they were going to divide the circle up into something what we are going to call, and what everyone's going to call, radians, okay? Radians, radians, okay? And a radian is going to be defined as a slice of the circle where the arc length, now remember arc length, we'll just call a portion of the outside of a circle, okay? It's a portion of the outside of a circle. If you're comfortable thinking of circumference, it's a portion of the circumference of a circle. Okay, they're going to define a slice of the circle, a radian, okay, where the arc length is equal to, what do you think that arc length is going to be equal to? Well, if you think of the name radians, it's going to be equal to the radius, where the arc length is equal to the radius. So let's think about that. Let me draw that for you for a minute here. So we have this circle with a radius of r, okay? That radius of r has a length. It could be 5, it could be 10, it could be 20. It all depends on how big your circle is. But they're going to say that we're going to divide a circle up into these slices called radians, where each slice of the circle Okay, there are two radiuses, or radii, where the arc length, and I'm going to highlight the arc length in a different color. Okay, let's do red here. Where the arc length here, okay, that length in R, you can almost imagine a piece of string. If you were to lay out a piece of string, the length of that string is also going to be length R. So you have the radius of the circle equal to the arc length of the circle. Now notice, it's really no different in degree in the sense that it's just taking a slice of the circle. This slice just happens to be bigger. Okay, it's a bigger slice of the circle. Okay, now you can imagine again, okay, that another radian slice fits in the circle. Okay, let's maybe use a different color to highlight that. Let's use blue here. The length of that arc length in blue we'll also call R. Okay, so how many radiuses do we have in terms of our arc length now? We have two, right? We have two radian slices whose arc length is equal to R. Okay, so we have one, let me switch colors again. So here's one radius, here's two radius, and you can imagine if we drew another radian slice, another radius would fit in on the arc length here. Okay, so that's what I want you to know just for now in terms of what a radian is. It's basically a portion of the circle, right, where the arc length is equal to the radius. And the nice thing about this, it doesn't matter the size of the circle. If the circle is tiny or whether it's huge, radian is going to be the same measure. It will move in proportion. Okay, so a bigger circle is not going to have more radian slices in a circle than a smaller circle. So that's going to be one of the nice things about it. But my question to you is, okay, my question to you, okay, is how many times, okay, can we fit the radius of a circle, okay, on the outside, okay? And if we know how many times, I'll use yellow now, my last color. We know how many times, there's another arc length, there's another, again, radian measure. I'm gonna do this really quickly, right? How many of those radian slices can we fit in? Okay, how many of those radian slices can we fit in? If we can figure out how many times that radius fits around the circle, okay, this will tell us how many radians are in the circle. And that's exciting, so I'll make it a couple exclamation points. Okay, that's going to tell us how many radians are in the circle, because we know each radian is basically a slice of the circle where the arc length is equal to the radius. Okay, so that's the question I want you to think about tonight, when I want you to come in tomorrow and tell me what you think the answer is. I don't care if you're right or wrong, but I want you to have a reason for it. Okay, so I'm going to ask you what your rationale is. Okay, so a little hint is based off the definition of a radian. The question is how many radians fit into one circle, and the hint I'm going to give you, okay, the hint I'm going to give you is I want you to use the formula for circumference to help. And if you don't know it, try Googling it, asking a friend, okay? But I want you to use that to help you figure out how many times the radius will fit into a circle, and that will tell you how many radians are in a circle. We know there are 360 degrees in a circle, okay? How many radians are there in a circle? There's 360 degree slices. How many radian slices fit into a circle? If you understand that, okay, that's going to give you a big advantage as we move forward here, okay? That is it. We'll talk to you tomorrow.